All right, for the second example, I want to just reuse the same data. Let's run linear regression on exam 2 and 3. So just, predicting the second exam based on the first didn't help very much, but maybe we could predict the third based on the second. Maybe this early semester stuff was too much like pre-calc, and once we got to the second exam, we were started doing more new stuff, so maybe there's more of a pattern of the high scoring students scoring higher and the low score students scoring lower. So let's see what happens if we do a regression using exam 2 on the x-axis now and exam 3 on the y-axis. So we'll change the x-axis to exam 2, change the y-axis to exam 3, and then rerun our test. See what we get. Now the r-squared is still approximately 33%, so this one isn't going to be any better. These dots are going to be all over the place again. And there seems to kind of be a pattern here, but actually not really, because this line is pretty horizontal. Basically just because the exam 3 scores, so many people got close to 50. So like all of these people up here between 45 and 50. It didn't matter if they got perfect on exam 2 or they got a 60% on exam 2. There were a lot of people who got in the 90s on exam 3. So it's true there is a bit of a pattern here, but it's more of a pattern of like, it doesn't matter what you get on exam 2. Exam 3 scores were going to be good. So when I say things settle into a line, it shouldn't be a horizontal line. If the line is horizontal, then it doesn't matter what the x-coordinate is. The y-coordinate always comes out the same. A pattern should be a line that actually has some positive slope to it, or possibly negative slope to it. That would mean that you would change your guess based on the x-coordinate. And if the dots were very much like sorted into a line, then that guess should be pretty good. But this time, our r-squared is still down in the 30s, very bad. Our guess based on this line is not going to be very good. There's this clump where all these people just got 90s regardless of their x-coordinate, and then the ones that did get in the 90s, they're all over the place. Some of them got low scores on exam 2, some of them got high scores on exam 2. Exam 2 is not really helping us guess exam 3. So we were able to run linear regression here, but it didn't give us any useful information other than the fact that there is not a strong association between exam 1 and exam 2. Since that didn't take very long, why don't we do one more? Why don't we do exam 3 and 4? Okay, so if you know exam 3, can you guess exam 4? We'll put exam 3 on the x-axis and exam 4 on the y-axis. I'm starting to think that, yeah, again, no. So somehow, like, there isn't just sort of like students who get good scores and students who get bad scores, like, on each exam. Like, from one exam to the next, it's not clear who will get the higher and lower scores. Some people are good on some sections, other people are good on other sections. Some people are good everywhere, some people get low scores everywhere, some people are up and down. We can't really tell. So another very low r-squared in the 30s. And so again, there's a slight upward trend, but this is basically like a square blob. It's not like things are settled into some kind of like line. We'll have an example after this where things are more like a line, but so far our examples are not very much in a line. All right, so that's enough for this video. We'll have a completely different example in our next video.